Hello, my name is Hany. I'm a teacher assisting at Faculty of Engineering, Mini University, Electrical and Communication Department. I will speak about my research with this topic, Braille code classification tool based on a computer vision for visually impaired people. Okay. 2.2 billion people worldwide are blind or visually impaired, face many difficulties in learning to write and read with Braille tools. What is the problem? The problem with blind or visually impaired people, they need a trained teachers, a good teacher to teach them how to read and how to write. So you need to have your personal tools for writing. And if you go to buy one of the writing tool, you will find it is very expensive. If we look, almost all researchers introduces tools for learning how to read, not how to write. Reading tools, we can find a lot of reading tools available. Maybe you know this is a finger reader. This can read text with a voice. Also, there is a device who reads the text in English and display in a cell. Refreshable display is a way to make a blind people or visually impaired to know how to read text by Braille cell. There are a lot of reading tools, so we focus on solving the problem of writing tools. We need to solve this problem, the existing writing tools and the problem with it. The first tool blind people use, it's called Slate and Stylus. This tool is very slow for note taking. Also, this require a special paper. You have to buy a special paper for Braille to write on it. It is not providing any feedback. It's cheap, but have a lot of problem with it. Perkins Brailler is the standard writing tool for blind people. It is a mechanical device. It is also a heavyweight device, so it is not a portable. If you need to have a portable device, it is not a good option for you. The price of Brailler is very high. There a new version of the Perkins Brailler called Mountable Brailler or Smart Brailler. This is a new version of this Perkins Brailler. They have a lot of features like storage, audio feedback, and a lot of features. What is the solution here? We need to provide a low-cost writing device. We need to provide a low-cost writing device. It is also need to be portable, and we will make it based on computer vision technology, so it will be very low price, as we will use a smartphone as a text detector. Our solution divided into stages. The first product is to provide a writing device. This writing device is a very simple and low cost device. It is only consists of buttons and LED. This device, we use it to produce a dataset. This dataset, we will train a model on this dataset, so the final product can be a novel writing techniques. You will use your device to write any Braille cell, and your phone detect the corresponding English character. The phone will pronounce the text, so you have a feedback. Also, text what you write can be stored on the phone, so you have a storage on your phone. Through our journey to produce this device, we goes through developing many versions of this device. These two versions, it is not a very good one, as the mechanical design is not good. So we decided to make a 3D printing version. This version also we found it is a good and very compact in the shape, but the mechanical inside is very complicated and not working good. So we decided to make a final version consist of only buttons and LED. The final version of the device consists of LEDs to form a braille cell for English characters. This cell perform it's like a braille cell with extra two LEDs. We will speak about them later. And also we have buttons with the same arrangement of the standard braille writer. This arrangement of the button have the standard of the Perkins Brailler buttons. So we have developed a custom braille cell. Why we call the custom braille cell? As braille cell, as we know, it consists of just only 6 holes, but we added 2 LEDs extra. The LED number 7 represents a space key, and LED number 8 represents a new line. So the extra 2 LEDs enable the model not only detect the alphabetic letters but also detect a space between words and the new line action. The layout of the final device may be found as it is. The button 1 corresponds to LED 1, button 2, LED 2, button 3, LED 3. Space button with the space LED. Button 4 with LED 4, button 5 with LED 5, button 6 with LED 6, and the new line button will light on the new line LED. And as we mentioned before, the arrangement of the button similar to the Perkins Brailler. We created many datasets with every version of this device. We created many datasets with this device and with this device and with this device. The final dataset, we will discuss it with you now. The dataset consists of 2,200 pictures, 1,931 pictures for training, and 259 for testing. We divided our dataset into training and testing. All pictures taken from various angles with a different brightness, so we consider every conditions that people will use our device. You can see here it's this light, this is a shadow with this area, and this another image with a shadow from here, and a lot of this is not with an angle, it's not a straight. So we make many scenarios if this person will use our device. The set consists of 37 characters as the Braille characters. Now we're gonna develop our deep learning model. We use a MobileNet v2 architecture, as MobileNet v2 architecture is a good choice for learning our model. The model consists of input image and block 1. The main part of our project is a mobile vignette and the custom head. So we use the mobile vignette with 2 blocks added. The first stage we call the block 1. You can see it here. The block 1 labeled is for resizing the input image to fit with MobileNet v2 architecture input. We resized our input image to be light. And second stage is labeled MobileNet v2 here. This is the main part of the proposed model used as a classifier. We use a mobile vignette as a classifier. It's more efficient and simpler in calculation. So we need this model to work with a mobile phone. So it is a good choice. The third stage label is custom head. Our custom head consists of a global average polling 2D followed by a dense layer with 37 output class using a softmax activation function. And we will go through the training process. The first stage of the training process is the image pre-processing. Image pre-processing is a way we scale pose a training and test imagery to a range of 1/255. Also, we reformat our images to be in the matrix dimension, like we mentioned before. The feature extraction will be applied by transfer learning on MobileNet v2, which pre-trained on a large dataset like ImageNet. The mobile VNet, as we know, it is a pre-trained model on a very large dataset like ImageNet. So we just only use a transfer learning to deal with mobile VNet to extract the feature from the image. This is setting for our model. Optimizer is a root mean square propagation. A loss function is cross entropy, categorical cross entropy. Number of epochs is 100, and patch size for each epoch is 13. Our learning rate is 0.001. The final stage of the model training is a classification. The classification step involves employing the softmax activation functions. We use an activation function for detecting the correct class of the input image. Result and analysis. The accuracy of detecting the English character corresponding to Braille code reached almost 97% as shown. Also, the losses, it's almost 0.19. These results make us completely confident this model can work. In the future, there will be a lot of features and a mobile app will build on this method. Also, we can find the convolution matrix, all the data in the diagonal, which means our model is very good. It's output result of the model. This is the output result, which compare true label and predicted label. We can find here this is a Q class, and predicted class is also a Q. This is a I class, with the predicted is a Y class, and the C class and G class, and a lot of classes. The only one can find here is the enter class. The true label must be an enter. This is the extra lead we added to the model, but the predicted class is about a capital letter. If you find the capital letter, you may find this. The lid must be light on and all the lids be off. So we consider our solution is a writing a tool. It's very low, with high accuracy, and affordable for every children to have it in home to practice on writing. I need this solution to be as a teacher in a home. You don't need to write in a paper. Just write with the device, and here is a correction of the voice and pronouncing voice. If you write it correct, it's okay. If it's wrong, you will try. This is a new direction of typewriter tools based on a computer vision instead of expensive electrical tools. This tool we will take another direction of producing a writing tool. So this model provides a foundation for a development of a mobile app. This mobile app is considered a self-learning Braille writing techniques, or a teacher. You have a teacher in a home. Thank you for listening, and I wish this solution open a new area of innovation based on a computer vision. Thank you very much.